In this video, we're going to do an introduction to fractions. So we kind of break down the concept of fractions first. And the author of this textbook breaks it into three basic categories. The first category is kind of what most people think of when they think of fractions. It's the part to whole concept, meaning we think of the fraction as representing a part of a whole. Sorry, that was like a really exaggerated T. Okay. So the idea is if we have A over B, A is what we consider the number of parts, and I'll say being counted or being considered. And then B is the number of equal pieces that make up the whole. Or what we're looking at in general. And of course, we do have some terminology when we talk about these two. We refer to A as the numerator and B as the denominator. Just want to throw that terminology out there in case it's been a while. All right, so let's just look at some examples. So here, I'll draw a couple simple ones, and then we'll look at one that kind of comes from the book that's a little bit more exciting. What part is shaded? Okay, so here, we'll do a part A, part B. So for part A, I'm going to go ahead and draw a circle. And I'm going to divide it into 8 pieces. So half and then half again, and then I'll split both of those. And there you go, 8 pieces. Now, of course, I mentioned before, I have a really hard time drawing diagonals on this Surface Pro without it being squiggly. So I'm sorry for the squiggles. Okay, and then here I'm going to shade in this one, and that one. There we go. There's my shaded pieces. Okay. And since I already told you that there's 8 pieces total and you just saw me shade 3 of them, then 3 out of 8 is shaded. Okay. And then the other real common one we like to use, it's a little easier to draw, is a rectangle. And let's go ahead and we'll keep it simple. Divide it into 4 pieces. And I'm going to shade this one. So this would be 1 out of 4. Okay. So let me go ahead. We're going to refer to a problem from the section. So this is page 263. We're going to look at number 2 on page 263. All right. I'm going to attempt to paste it in. Hold on one second. Let me do that. Okay. Forgive me. To do that, I actually paused the video because it was going to size very weirdly and I didn't want you to have to watch that. So here we go. This is the basic picture from the problem, and they ask us to identify each labeled piece as a fraction to the whole. Okay. So like they referring to rectangles A, B, C, D, and E. So rectangle A, and we're going to assume the simplest version, okay, for this. So rectangle A definitely looks like half of this whole figure. If I'm considering the whole thing, I'm thinking it as a square. A definitely looks like it's half of the square. Okay. Then B looks like it's half of A, right? Or if I'm thinking of it in as the whole relative to the square, I could think of it as they're dividing up into 4 different squares that would all be equal to B. So I'm thinking of B as 1/4. And then to me, C looks like it's breaking it up one step further, right? We're kind of dividing each piece like this. So that would be 8 equal pieces. So C would be 1/8. And then here's where it gets fun. D and E. So D kind of starts off looking like C, but then it's like they took a corner out to get E. Now here's how I kind of like to think of it. I like to think of E as kind of, rather than just a triangle, as if I had two E's, right? Like two E's like that. They kind of form a square. And to me, it looks like it's relatively half of D. Okay. So each of these little squares here, I don't know why I erased all those rectangles that I worked so hard to draw. What a silly person I am. All right. Okay. Each of those rectangles then are dividing into 16 pieces. Okay. So I'm thinking of this as a 1/16. Okay. And then the diagonal is basically cutting it in half. So that means if we're having it, there's going to be 32 pieces. So I'm thinking E is going to cut them into 32 pieces. If I matched all of those little triangles, right, I'd have 32 total. Wow, my diagonals. Terrible. Okay. I'm not going to do them all. All right, 32 total. But then D, to me, when you kind of look at D, what's left over, in fact, here, I'll erase all the rest so we can kind of see it a little clearer. To me, D looks like it's composed of 3 E's, like 3 of what E is. So to me, it makes sense to think of D as being 3 out of 32, 3 of those little triangle pieces. So that's how I kind of approach that. I try to think of it as how many, if I break up the whole, how many I have left. That's the part to whole concept. Okay. So the next concept they explore and is also really common is the fraction quotient concept. And hopefully you remember quotient is the fancy math word for division. In other words, the fraction can be thought of as a division. Okay. And I mean, it's really only exciting when the division doesn't work out nicely. Let me kind of give an example of what I mean by that. Let's say you're told to divide. Oops, that's not how you spell divide. Divide 25 by 50. So because it doesn't go in nicely, right? What we want to do is we want to think of um, how we could actually take 25 things and divide it into 50. So you might remember that we had some different ways we looked at division previously. And if you weren't with us last term, you might not be as familiar with it, but it was the measurement. Wow, that's supposed to be one word. Measurement versus the sharing. These are the concepts we had for thinking of division. So with measurement, you're thinking of subtracting repeatedly, subtracting. Okay. With sharing, it's thinking of it as like a dividing it into parts. So they called that partitive. That was the alternate name. So dividing it into parts. Okay. So in this case, it would be difficult to think of taking 25 and subtracting repeatedly, right? That doesn't make sense. But it does make more sense to think of how you could divide 25 up into 50 pieces. So if you have 25 things, right? So I'm going to do a terrible drawing here. 25 little circles, right? Try to just go quick. And one more. If I want 50, all I need to do is half them. And now I have 50 pieces. So the answer then is half. That's going to give me 50 things to share. Okay. There is another way of thinking of this. And it is kind of using the partitive way, dividing it up. So let's say this time I'm going to work with something a little bit smaller, like 3 divided by 4. Okay. So here's how we could do this. If we have 3 things, well, I'm going to try to draw a rectangle here. that represents three distinct things here. Okay. All right, so let's see. 3 rectangles. Try to make them as equal as possible. All right. If I want to take and think of it as dividing it up into 4, well, it's kind of actually not too hard to visualize. You kind of say, oh, okay, so if I cut it in half and then cut it in half again, there we go. There's 4 pieces. And when I'm thinking of half, I'm thinking about these pieces here, like each of these. So, right, I'm having that portion. And over here, I'm having this portion. That's what I meant by having again. Okay, and then what you kind of look at is what's left, like what you have. So if you're starting with 3, we're saying then each of these pieces, what are they? What do they represent? Each of those pieces. So there's one piece here. Actually, let me do it distinctly. I'm going to backtrack on all my coloring here. Even the highlighter, because I think I'm going to use the highlighter. Okay, so this is one piece. And that piece should be the exact same as this piece. Those two should be the same. Okay. And the question is, what are they in terms of relative to the 3 that we started with, the rectangle we originally started with that represents one of 3 rectangles. Okay, how much of that rectangle is shaded? Well, I kind of going to use this first rectangle to help me. I'm sorry, the first rectangle I divided to help me. It looks like we split it in half, right? So this to me looks like it's half of a rectangle. And to me, then this kind of looks like we've split that into another half of that. In other words, I'm saying I believe that this is 3/4, which kind of makes sense because 3 divided by 4. And what we're basically saying is that each of these pieces represents 3/4. Oops. 3/4. 3/4. 3/4. And if you add those up, which we haven't talked about, right? How to add fractions. We're going to talk about that in the next video. If we were to add those all up, that ends up giving me 12 out of 4, which divides out to be 3. Okay, so that's the division version of the fraction. The last version, and again, it's still very common, is the ratio concept. And that's the idea that we can represent a ratio comparison. So when we think of A over B, we're comparing two things of the same type of measurement. All right. As an example, just to verbally give an example of a ratio where the two things are the same type of comparison. So like, let's say the class size at your school is 1 to 15. 1 to 15. So what that's saying is for every one teacher, there's 15 students. Okay. The thing that's the same is that we're literally counting people. So the measurement here would be people if I'm using 1/15 as a way of saying that there's a ratio for class size of 1 to 15. Okay, so that's an example of what I mean by ratio and same measurement. Okay, so the book does these kind of examples with rods. Like they kind of build on these kind of like rectangle examples. And they say, okay, so let's say you have 4 red rods. And again, I'm just kind of thinking of the word rod as a rectangle. And that 4 red rods equal the size of 1 brown rod. And then let's say they tell us that 5 white rods equal 1 yellow. All right. So they kind of word this interesting, and it's kind of why I wanted to go through this. If the brown rod represents 1 unit. Or they actually say, if the brown rod is the unit. And what they mean by unit is they're meaning like what we're kind of considering whole, the whole piece. Okay, what we count as the whole. What is the length of 1 red rod? Okay. So what we're saying is, if brown is supposed to be the whole, quote unquote, and 4 red rods equal 1 brown rod, excuse me, then it would make sense that 1 red rod would end up being a fourth of what a brown rod is. So 1/4, and that's it. That's what they're asking. Let me give you another example just to kind of solidify that. If yellow is the unit, so they say if the yellow rod is the unit, what is the length of 3 white rods? All right, wrote it down. Answer the question, give it a guess. And I'm going to guess then. So if 1 yellow rod equals 5 white rods, you can think of 1 white rod as being 1/5. But if we have 3 of them, 3/5. And there you go. That's how the book kind of really gets into the ratio concept.